Welcome to Building Safety webinar series, safety case report preparation for high-risk buildings. This is number 7 in the series on the topic of Bowtie analysis. So these slides are my own ideas and presentation, or if not, give references. They're not necessarily represent those of the IMechE or any other organization. This safety case process is currently developing. It's quite a new thing and there's rapid change. This series of webinars is designed to assist building safety management teams and so on who are concerned with safety in high-risk buildings. It's based on the work of so-called WG1, which is a working group of engineers set up to support the recommendations of the IMechE report and led by the Engineering Council. We hope these will give people some ideas to help them with their work. They're really only introductions to the topics, and hopefully they will signpost the way to more detailed training if you require it. So webinar number 7, Bowtie analysis. So we start with an introduction. What is Bowtie analysis? How to start, definitions, and then a bit about going on from the basic Bowtie and practical issues with using Bowtie in high-risk residential buildings. So Bowtie is a good visual tool and has been used across many industries. And it's used for modeling hazards and threats and barriers. And this particular webinar is targeted at safety in occupied buildings, but Bowtie's analysis can also be used as a general method in building design phase or any other system design, really. It's generally accepted that the earliest mention of Bowtie methodology appeared in an ICI course given in Australia in 1979, and it's also generally accepted that Shell developed this technique a long way, and most of the techniques are based on their work. There is a government link to the defence part of the government where they use this technique. So this is an early version of a Bowtie. It comes from the American Institute of Chemical Engineers, but I think this is a little bit easier to understand than the current layout. So on the left-hand side of the diagram is a hazard, for example, fire, and then we have what we call initiating cause. So, for example, if the fire door didn't work properly, that would be an initiating cause. And then the little sort of hatch things are preventative safeguards which stop the fire spreading. And then we have a loss event. That means the fire has, as it were, got away and is spread around the building. And then we have mitigation safeguards. That's things to try and prevent the loss from the fire to a minimum. And then impacts are what we today call consequences. So that's a sort of easy to understand left to right version of Bowtie. So one of the industries that has adopted Bowtie in quite a big way is the Civil Aviation Authority, and there are some links there to their various practices using Bowtie. You'll see a little diagram at the top there is the format they use in which the hazard is being shifted to the top of the diagram, and we start with the what we call threats or initiating causes in the previous diagram, and then the main event in the middle, and the consequences on the right-hand side. But one of the things which the CAA identified, which I think is a useful concept, is the idea of independent hazards. They call them significant 7. They identify 7 independent hazards. So as an illustration, for example, if there's something on the runway, obviously this is a big hazard for a plane, But if there is say a problem in the plane itself, something goes wrong in the plane itself, the air won't come down, for example, then those are two independent hazards. They're not connected really. So each of those should be given its own bow tie diagram and analysis. Here's a diagram from another part of the aviation safety industry. And you can see on the left-hand side, you've got these types of independent hazards. So a maintenance error, flight ops hazard, hazard on the ground, and so on, weather hazard. Then in this case, they've used a sort of ring to indicate the barriers to stop this escaping. And they call their event an undesirable operational state. I quite like that, undesirable operational state. And then the three rings are their mitigation hazards to try to minimize the accident outcome. So at the top is the catastrophic situation, at the bottom is negligible. So again, this is easy to understand, I think. So the railway industry also uses bow tie a lot. And here's a connection to their site. And there's actually quite a nice podcast over there given by Mr. Gil Martin. And there's extract from their site. You can see their diagram has grown a bit from the one that CAA had on their site. And they've understood that barriers can deteriorate over time. And this deterioration over time needs to be thought about, and in particular, how we think about controlling this deterioration and correcting it if necessary. So how do we start on a bow tie? Well, it's a group activity best, and in fact, similar to the hazard process. So you could start with your hazard team if you have one. And there is lots of software about, but I would suggest you start with a whiteboard exercise or sticky notes, for example, before you invest in any major software, because they're quite expensive. And the clarity you get from a whiteboard or sticky note exercise is you can really see what's happening and you can move things around easily. So that would be my recommendation. Building webinar number 6 talked about setting up a hazard team. So you might want to look at that. So here are some fairly standard definitions. I think these are pretty much accepted across different industries. So a hazard is an activity or a state of something with the potential to cause harm. So in a building, obviously, if you have gas, that's obviously a hazard. An event is a situation where the hazard has got out of control. That's sometimes called a top event. And a threat is a factor which causes the hazard to become out of control. So in the case of, say, gas, a gas leak would be a threat. A risk is a likelihood of an event occurring and causing consequences, and consequences are the result of an event, and mostly we're concerned with the effect it might have on people, which is harm or in most cases fatalities, but also consequences, for example, damage to the building, so people could lose their homes, and damage to the environment, which could be large smoke escape, for example, which could blow into other buildings. And then also reputation is usually included. And reputation means that if your building becomes known as somewhere where there's lots of bad events occurring, people won't want to live there. So that's a consequence of bad reputation. An issue is usually referred to as an event which is already going on. And a barrier is a control that is designed to prevent the hazard from getting out of control or to mitigate the consequences of an event. And sometimes that's called a risk reduction measurement, in short form RRM. So here's sort of a bit of an example of a bow tie just to get started. It might be an older building, we say 12 stories, no sprinkler system, a fire in a flat, and potential event is fire spread. So here's a cross section through the building, plan view of a floor, typical floor. And in this case, we're looking at preventative barriers. So there's a hazard is a fire in a flat. And this is probably a CP3 type of design from that age. And you can see that the fire doors coloured in red, those have 30-minute fire resistance. And there are a couple of those at the top of the stairs which have 60-minute fire resistance. And then we have walls with 60 minutes between the flats, and to have walls with 120-minute fire resistance around the lift and stairs. So these are our protections. So we've got preventative barriers we can consider as compartmentation walls, fire doors, and perhaps we should also include lifts and stairs as one of the preventative barriers. So here's a way of showing that, and with this bow tie analysis, you really can develop your own way of doing it. Basically, on the left-hand side of the diagram are the preventative barriers, and then in the middle is the event that you're trying to prevent. And later, next, we'll show you the mitigation side on the right-hand side of the bow tie. So I put there, again, the walls, doors, and lift with a question mark, whether you want to call those preventative barriers or not. So here's the right-hand side we're coming to. So we're looking at mitigation barriers. So smoke ventilation is obviously a very major mitigation barrier, must be working properly. And then means of warning and escape, which, you know, we refer to the proof document B, means of warning and escape. So here are with the bow tie with both sides on it. And I've done it in the slightly older form there with the fire in the flat as a hazard on the left-hand side, then the preventative barriers on the left-hand side. Building fire is where fire spread has happened. Mitigation barriers, smoke control, warning system, evacuation, and consequences. So in 2017, the Institute of Chemical Engineers held a conference called Hazards 27, and a couple of very useful, or posters actually, poster papers presented there. And this particular one talks about the standardization of bow tie methodology. And I think it's quite useful. So it gives the definitions, which I covered just before, and also takes about different types of barrier. So passive barrier might be a fire door, for example. Active barrier would be something like a fire alarm, which reacts to something happening. So here is a typical standard form from this paper, and you have a threat on the left-hand side, consequences on the right-hand side, the hazard at the top of the drawing here, and you can see that they've shown some of the threats and then a preventative barrier, which is degrading. They call it degrading, which means it's getting less effective. And then they put in a safeguard, which is the measurement system or the policy or whatever you like to have, which looks at this degradation, keeps an eye on it, and corrects it when it occurs. So you might say something like a fire alarm system, the battery life, if it's got batteries, that might need to be recharged from time to time. And here's another slightly different form, which actually is used in our safety webinar number 9, the risk assessment, and more or less the same kind of thing. But in this case, we've got prevention on the left with possible threats of electrical fault or human error or arson, and then the fire starts, in this case, in flammable materials. So this is probably fire in a common area. And then on the right-hand side, the mitigations and the possible consequences. So the main substantive recommendation proposed by this poster that I referred to, and the link at the bottom, is that the bow tie terms become clearly defined, and particularly they concentrate on the case of barriers. And they say that you should remove any human factor descriptors. So procedures, training, competency should not be called barriers by themselves, and they shouldn't be in the main threat line they call it, on the pathway. So this does not reduce the importance of these human factors, but they can't stop the actual trajectory between the threat and the top event. So they're not really barriers. They are, however, vital as safeguards to ensure that barriers perform as desired. I think this is a very key point in understanding your system. I'll just diverge a little bit at the minute and show you, this is an extract from HSE report RR1170, which they published, and it's a little bit difficult to see that diagram. So I just extract from that, and above the red blocks is preventative barriers, and above the blue blocks on the diagram are mitigation barriers. And you can see there that they've actually put in quite a few human factor barriers. So you've got fire safe design, for example. Well, design you could consider is a physical barrier. Building management and competence, definitely human factors, I would say, change control, and so on. And then on the mitigation side, that's better really. You've got alarms, suppression systems, communication systems, and so on. Signage, very good. Ventilation, firefighter access. So on the mitigation side, we have much more physical, if you like, barriers. So here's an example just to make clear what we're talking about. So we have a threat here with a barrier. The barrier could be passive or active. And then there's the event which we're trying to prevent. And we're looking at barrier degradation. So the barrier's perhaps losing its full ability. And we have safeguards which are looking at barriers on some kind of regular basis to make sure they stay effective. And the safeguard system is part of your safety management system. So it might be that you have a contract with somebody to come in and check these barriers from time to time. It could be you have some types of barriers, active barriers, which have a continuous feedback to the supporting service organization. So another concept, which I think is a very useful one, although we probably only use it to a certain extent in the residential building industry, is layers of protection. So this is a very simple process engineering example. And we're talking here about a pipe as excess pressure has occurred due to some process problem downstream, which could be in a building, of course. And we've got three different preventative barriers here. We've got the original mechanical design and condition of the pipe. So this is analogous with the fire-resistant design of a building, I suppose. But in this case, with a pipe, we might say that the pipe is designed to withstand perhaps 2 times the normal working pressure. So even though the pressure has gone high, the pipe should be able to withstand any normal incursions. And also we've got the condition of the pipe, making sure the pipe hasn't become rusty and therefore losing its strength through corrosion. And then the second preventive barrier here, we've got a process control alarm. So that would be, in this case, a pressure gauge of some sort, which sends a signal to the control room or to some supervising area and saying, wait, there's overpressure here. And then the third one is this kind of final barrier, which is a pressure relief valve, which will actually open at some preset pressure and let the pipe go out to waste somewhere. So these 3 levels of protection will stop your pipe bursting, which could be a major incident. So this is level of protection. And we can also do this as a building safety example. And here we've got a fire and domestic appliance, smoke detector, sprinkler system, and compartmentation as 3 preventative barriers to stop the fire spreading out of this flat of origin and into the general building. And here's an example with the sprinkler system. So we have a fire and a domestic appliance in a flat, and that flat has a sprinkler system, but it's also a smoke detector. So hopefully the smoke detector will alert the occupants of the flat early, and they'll be able to do something about the fire. But if not, or for example, they were out, for example, then the sprinkler system should spring into action based on the heat in the room and stop the fire spreading. But if that fails for some reason, for example, there's pressure leak in the pipe leading to the sprinkler system, and then we're relying on compartmentation to stop that fire spread going to the other flats and the rest of the building. Here's another example with no sprinkler system. So in this case, we've got the smoke detector perhaps in the room, and then we're relying completely on compartmentation to stop the fire spreading to the rest of the building. And then smoke ventilation is probably our biggest mitigation, most important mitigation factor to stop the various consequences. So here's another example where we've got sprinklers just in the common area. So we've got fire in a flat, and we've got a smoke detector and compartmentation as preventative barriers, but the fire spreads. And then we've got a sprinkler system in the corridors and smoke ventilation, and that's quite an effective mitigation combination, I would have thought, to stop serious consequences. So here we've got a sprinkler system in the common areas, but fire in the common area. So here we've got fire in the common area, so there should be smoke detectors in the common area, and then the common area sprinkler system works. So that should stop fire spread. But in this case, compartmentation is definitely a mitigation barrier because it's trying to stop the fire getting into people's flats. So this is from the common area into their flats. And then smoke ventilation, again, is an important factor. Just for references is Swiss cheese model. I put a little diagram on each of those previous ones. So the idea that James Reason proposed at the University of Manchester some while ago was that no preventative barrier is ever 100%. But if you have a series of barriers, in other words, layers of protection, and then between them, they will generally do a pretty good job. In this case, he shows 3 layers or 3 pieces of cheese. So here's another way of showing your bow tie. You might like to do it this way. In this case, we've taken 3 different threats on the left-hand side. So it said fire stopping has not been done properly, so the walls are not as preventative as they should be. We might have non-compliant doors, so the fire doors aren't as good as they should be. And then the lifts, we've perhaps found that fireman's switch is not working, or if the lifts have some other fault, then they also are not helping with the overall preventative barriers. And then on the right-hand side, I've left that in the same format as smoke control, warnings, and means of escape, evacuation. So quite often in software systems, you can add additional information to your barrier diagram. And this is sometimes referred to as barrier metadata. The sort of additional details you might want to attach to your barriers is who's responsible for that particular barrier, what's the condition of that barrier. So for example, you have a rusty pipe, or some of your flat walls are not completely good on fire stopping, or maintenance is not being carried out very well. So we need to know what's the current state of the barriers, and then degradation and fire safeguards, as we discussed. So in Building Safety Webinar number 10, part 2, there's a description of how one company keeps track of its fire doors and ensures legal compliance with the latest fire safety regulations. So they've put digital readable tags on each door so they can keep tracking them. So there's several different kinds of software around for doing bow tie analysis. This is quite an old one called Active Bow Tie, but I quite like it because it allows you to connect your safety management system to your bow tie quite nicely. One which is quite commonly used is Bowtie XP. That allows you to have a very complex software system. I really don't recommend you go straight to this level of complexity. It's best to start, as I said, with a whiteboard or sticky notes and get your basic underlying system clear before you start adding all these different connections like control and who's responsible and documentation and so on. All of which are important, but you can confuse the diagram. This also shows how the risk is calculated. So here you've got threats, barriers, and consequences given red, yellow, and blue, red, yellow, and green. And as we know, the overall risk is the threat likelihood, consequence severity, and the barrier effectiveness. So that's a way of calculating the risk. So here's just kind of another form of this bow tie diagram, but in this case, I've been able to link up the safety management system, which we talk about in bow tie number 10, through maintenance of sprinklers, for example. Fire risk assessment is another kind of inspection, maintenance of the smoke detection system and ventilation. And that shows you the connection between your bow tie diagram and your safety management system. It's important to have that in your mind. So this is another useful diagram from the American Institute of Chemical Engineers. And on the left here, we have a hazard control lost. So some kind of hazard, might be gas, for example. So the control's been lost. So we're reliant first on the preventative barriers. So if they work and they keep control, then control is regained. But if they don't, and then we're then reliant on the mitigating barriers. And if they work, consequences can be averted, but if not, we have a loss situation. So human factors. So as I put before, the report which was given at the Hazards 27 conference suggested taking out all the human factors from your bow ties and putting them into the form of safeguarding and keeping control of your barriers. So in high-risk residential buildings, there's a couple of things we have to think about which affect this a little bit. The first is that without any human factor barriers considered, only physical barriers, then the level of protection is often quite low. There may be really only compartmentation in some cases. And the other thing, which really is perhaps a key factor, is that the humans involved in a residential building are mainly residents, not employees. There's some employees, obviously, but mostly we're residents. And residents, we can't tell them what to do. We can try to inform them of the best things to do, and we can give them as much information as possible. But they are individuals who live there, and they have their own ways of doing things. So it is a different situation from, say, a process situation where mostly the people on board, say, an offshore rig, are going to be employees, or at least contracted under some form of contractor or control. So you can assess their competence and train them. You can't really carry out a competence assessment on residents and then tell them that they must undergo certain training before they can live there. That doesn't really work. So it is a different situation. And I think it's more like the situation in a civil aircraft where passengers are not 100% under the control of the airline. They are individuals. So that makes it a bit more difficult to use these processes of analysis in the human residential environment. So now to finish, we've got an actual example of an HRB in a high-risk residential building. And this is an interesting one. It's what we've done here is the manager of a group of buildings in London has kindly provided this data and his analysis as an example. And this is an existing estate of 163 high-risk in-scope buildings. They're all managed by the same company, and they have a similar mix of residents. They're multi-storey residential buildings with open plan flats, and they're all monitored by the same systems such as fire risk management and computer-aided facilities. The buildings vary a little bit. They're spread across 10 sites across London, and each site has a slightly different design. And the management team is individuals who operate on their own sites. So as a result of this, we've got data recorded since 2018, so that's 5 or 6 years worth of data. And that gives the details of all the incidents that have occurred across this estate of 163 houses. So I think this is very useful kind of input to the Bowtie model. And it's a bit different from the hazard data, which will be really looking at potential incidents across a particular building. This is looking at actual incidents across a sample of 163 buildings. And it came out with 6 different headings. The first one was benign incidents, which is where, for example, fire alarms have been set off accidentally or something like that. So they're discarded and, well, not discarded, but put on one side for this particular analysis. So the next 3 types of risk are the ones we're considering here. The first one is where the fire started in an individual apartment, and in this particular case, this particular estate, they're mostly cooking related. The second one is fires which are initiated in external areas, mostly from smoking materials. And the third one is fire initiated in a communal area. So here's the Bowtie for these 3 types of incidents. On the left-hand side is the preventative barriers, and on the right-hand side, the mitigation barriers. So it's all one diagram, but it's not easy to read like that. So I've taken the first one on each side and blown it up. So here's the preventative barriers. And, well, you can form your own opinion about these, whether they are human factor barriers or not. I think that the manager's tried to colour these in. So he's coloured in the first one is electrical systems. He's given that a yellow, which means it's a sort of moderately secure, but he's then put in a potential degradation there, and also a factor that resident engagement is only somewhat effective. So generally speaking, on the residential flats, management are not able to go in and demand to test all the appliances or whatever in a flat. So may be able to, but it's not as a general rule. So this is the preventative side. Just see if I can blow one of these up. I don't think I can do a blow up here. Well, you can probably blow this up yourself. So then this is the mitigation side. I think when you look at these in detail, you'll find there are far more physical barriers on this side, but again, quite a few of them compartmentation, for example. Typically, front door entrance doors might be degraded in some way or other, and various other things can be degraded. So there are some examples. So this is an actual Bowtie that's been drawn up by manager of these 163 buildings to try and use this analysis system. So I hope you find this effective. I think it's a very useful way of understanding what you have and what problems are and how you might deal with them. So thank you very much for listening to this. There's my contact details if you do want to get in touch. And I look forward to safer buildings throughout the whole industry.